So strings are a type of object, a special type of object. Now, objects are things that are more complicated than primitives, such as your scanners, your anything you use to represent a file. But strings are possibly the most important object that we get because they're so fundamentally used, and Java basically treats them as special objects. Most objects, as we'll see, they need the new keyword. On the other hand, the string object does not need the new keyword, so it has that advantage there. And what that means, and we'll see this in way more detail when we get into methods for the next couple videos, is that if I were to create an integer x here, x is equal to 5, and int y is equal to 5. Sorry, y is equal to x, right? First, this takes 5 and stores it in x. Then for this next line over here, we take what's stored in x, and we take it, and we retrieve it, and then we say, okay, that is 5, and we store it in y. On the other hand, when we deal with strings, such as this, string s is equal to hello, right? And string r is equal to s, right? Over here, what we did is that we took 5, stored in x, and then took what was stored in x and stored it in y, which meant that basically x was 5 and y was 5. And they were both different 5s, right? They were both different. They both had different values. On the other hand, with strings, as we'll see, it's important to realize that what is stored inside of s isn't the word hello. Why? Because it's really hard when we create a variable like this one, right? If we were to do this, string s is equal to hello. And this is a oversimplification, but it's a good one. When we create this, say, something like this, int x over here, Java knows exactly how much we need, how much memory is needed to store an integer. It needs 32 bits. On the other hand, strings represent text. That's what they're used for. They're used to put together strings of characters. So we have no idea how big that can be. That can be something as simple as hello, or as we'll see, that could be the complete works of William Shakespeare. That's a lot. And that's true for basically every single object, right? So we have no idea how much memory this needs. So as a result, and for other reasons that have to do with methods and passing things into methods, what gets stored in a variable isn't this data. This data gets stored somewhere else, somewhere called the heap. What gets stored in here is the memory location of where to find that data. So what gets stored in objects is the memory location of where to find the data, the address. It's the difference between the White House and 1600 Pennsylvania Avenue, the address of the White House. I'll have to double check to make sure that's the address of the White House now. Great. Okay, but it's the difference between the thing and where to find the thing, right? But the important thing to remember for objects is that we take that address, where to find it in memory, and we store it in this variable. As a result, when we do string r is equal to s, what we do is that we take the memory location and store it in r as well. So r and s both refer to the same string. So that's confusing for now. That's okay. That's not going to get in the way of you using strings. What will possibly get in the way of you using strings is something you need to remember. It's true for this in Python. So if you've learned Python, then this is the same rule here in Python as it is in Java. Other languages, not so sure about. But strings are what we call immutable, meaning they cannot change. Once we've created a string, this string hello, we can't actually change it. We can replace s with a new string, but we can't actually change its contents. But let's go ahead and play around with the string and see what we can do. Okay, so the first thing we've already learned one of the methods for that we can use for a string. So let's go ahead and do hello, how are you? We've actually know two methods. The first method methods being things that we can use strings for. Methods being calls we can make on-string objects to do stuff. Is the dot length, which will perform the tedious task of counting how big that string is. Right? This one, s.length, tells us this has 17 characters. s.char_at is another one we learned, which, given a index, will return what is at that character. What is at that index? So 7 produced that O over there, right? Because that's at index 0, 1, 2, 2, 3, 4, 5, 6, 7. So what will index 9 give you? Char_at 9. If you answered space, the answer is correct. If you didn't have enough time, I would recommend pausing the video, because that's the beauty of video. All right, so, and again, we can put any kind of text in here, any kind of valid Unicode character. I think even emoji is perfectly fine to put in strings. So system.out.char_at 1, that will give us an E. Surprisingly, the only E in there. All right. So other important things we can do with strings are, let's see, we can do concatenation is another really important thing, which means that we can take any string and use the addition operation to anything else, and that will turn it into a string. So here we've got s plus 3, and when we concatenate that, well, we've got a string adding to an integer. You can add anything to a string, and what it will do is that will convert the other thing to a string. So notice that the output is, hello, how are you 3? Right? Interesting. So that means, classic question that I ask freshman students is, on exams, is what is the value of 1 plus the string 2, 3, right? That should give you 1, 2, 3, right? Because the integer here gets turned into a string when we do concatenation. You can also concatenate it with other strings, right? That's the string 45, not 45, right? It is text over here. You can concatenate with other strings. I think there's even a .concat method, but honestly, you can just use the plus method. And remember, what this is doing is that this is producing a new string over here that is the result of the integer 1 added to 2, 3 plus 4, 5. Also, be sure to note that order of operations does take effect here. So if I did 1 plus 0 over here, it is still 1, 2, 3, 4, 5 because we're doing 1 plus 0 resolves into 1, then adding 2, 3, then 4, 5. Similarly, if I were to do 1 times 0, we'd get 0, 2, 3, 4, 5. If you are coming from Python, you may know that Python has the ability to multiply a string and a number. You can't do that in Java. That's Python being Python and Python being awesome like that and special. Other things you can do with strings before we get into the more complicated things. Let's go ahead and take s.to uppercase. This has the expected result of basically creating an uppercase version of the string. And I say creating because we're not modifying s over here, right? If I do sout s, we didn't turn s into an uppercase string. What it did is that this created a new string, which was the uppercase version of s, right? Remember, strings are immutable. That special term meaning they can't be changed. So it created a new string over here. If we want to save that string later, what we can do is say that s is equal to, if we want to make s uppercase, we can just simply do s is equal to s.to uppercase. So we create the new string, store it in s, then we print out s here, and now we're going to print out, hello, how are you, all shouty, twice in a row. So, unsurprisingly, there is also a to lowercase. And these are very useful if you're parsing text and doing something simple like counting characters. These are very, very useful functions. Other ones include, let's see, less important but useful ones are strip. I think that's what it's called in Java. I switch between languages a lot. S.strip. So here, notice that I have a bunch of leading and trailing space over here. So I made it all uppercase and then I printed it out. And it printed out, hello, how are you? And what the strip method did, right? Notice that there's spaces after this and spaces before this. Strip removed all the beginning and ending white space, basically formatting that for us. There's also the split method, but we'll learn about that when we get to arrays, which is a way of splitting up a string. The final one, which is probably the most complicated of these, is the substring method. The idea behind it isn't that complicated. It just takes some getting used to for the notation, to be honest. That's what makes it complicated. So let's go ahead and reset this to hello, how are you? Right? And let's go ahead and see what we can do, what we can make out of just simply looking at s.substring. And then it says a beginning index. So let's go ahead and give it 0, 1, 2, 3, 4, 5, 6. So let's just give it 7. And I added a comma so that it will differ. It will differ from 7 is different now because I added a comma in. And it will be, how are you? So substring 7. Right. Let's go ahead and add our commented guide into this. And we do so by going to all right. So substring 7, what that did is that it started at index 7 and produced a substring, a new string from index 7 all the way to the end. So substring is kind of useful. It gives us a piece of a string. Furthermore, we can give it a ending location. How? Without a space after it. So it went up to, but did not include index 10. Now, why does it do we do this whole up to but not including? Well, if we do 10 minus 7, we get 3. And this answer is, and the substring's 3 characters long. So what's a really nice feature is by doing this whole up to but not including and starting at 0 means that we can take the end and subtract the start and get how big the output is, which is really kind of useful. So that's substring for you. There's not too much more behind it. Just, again, it's that inclusive, exclusive notation, including character 7, excluding character index 10. One thing to note is that if we produce a number that's out of bounds, it will yell at us. And this is true for basically everything we do. If we produce a number that's too big, we will go out of bounds. The largest we can go is 19 to get the whole rest of the string. How are you? Right? There is no index 19, so going up to and not including it doesn't provide much of an issue.